Okay. Hi, everybody. Thanks for attending the one of the last sessions here at the Openstack Summit here. I'm Tim Swanson. I'm from Cisco Systems. I'm in the Cloud CTO group. And this is
I am Arvind Soumya, same Cloud CTO group, working with Cisco Systems on Istio, Openstack, and Kubernetes.
So we're going to talk about bringing Istio to OpenStack. We've done some work to validate the Istio and Kubernetes on OpenStack, and there's a use case in Istio that's supported called mesh expansion, where we include VMs into in the service mesh. So we're going to have a demo on that as well. So what I'm going to talk about is I'm going to start off with Istio and service mesh concepts in general. Then we're going to go through Istio and Kubernetes on OpenStack, some of the details that like OpenStack, specifically the cloud provider supports, and then just some integration things that we have to do to make everything work. And then we're going to go into the concept of expanding Istio, the service mesh, into OpenStack VMs to include them fully into the mesh. And then we're going to go through an Istio mesh expansion demo, and we'll talk about just a brief overview of some future improvements that could be done and give you some references on all this work. So how many people have heard of Istio, know a little bit about Istio, have seen earlier presentations on Istio? Okay, so probably half of us. So I'll go through what Istio is. So just try to not take too long on this. But basically, Istio is a uniform way to connect, manage, and secure microservices. Some of the key features that Istio provides are automatic multi-protocol load balancing, securing microservices, so having the connections between microservices be over TLS with full authentication, having a pluggable policy layer, so you can have some L7 sophistication there on your actual policies, and a lot of different options with respect to the behavior of specific microservices and policy with that, applying policy to those things. And then one big thing is metrics. So metrics, logs, and traces. So being able to just automatically get tracing information from how the microservices are communicating. So as an application developer, you just get that for free. All these things for free, really. So this continued here, the Istio architecture is built on a proxy. So what we typically call a sidecar proxy. That's kind of Kubernetes lingo. But what that means is there's, per microservice instance, there's a sidecar proxy that is coupled with that instance. And it's fronting the communication to the rest of the service mesh. And it's the thing that's actually performing the actions, like the TLS between other services, doing the routing rules, doing policy and stuff like that. So the Istio architecture includes a control plane and then a data plane. So I just spoke a little bit about the data plane with the sidecar proxy. The control plane for Istio is made up of these three main components. Pilot is the piece that discovers service information from the environment. So like in Kubernetes, that's your services and your endpoints from the Kube API server. Mixer is the piece that is doing policy and telemetry integration. And Istio Auth is now called Citadel, and it's made up of it's doing the TLS certificate distribution and authorization identity stuff. So we have Pilot. Most of the work that that's been done to integrate this VM expansion is just getting the VM recognized by pilot, and then having the VM be able to communicate with the rest of the control plane, like Mixer and Istio auth. So the Istio components continued. So just to reiterate, Envoy is the proxy that's injected in front of each of the microservice instances, aka a sidecar. Envoy is a full project in the CNCF. It's used in production by Lyft. It was developed by those guys, and it's used in production by outside of Istio. Istio is like a way of deploying Envoy and controlling it. Pilot is the thing that serves as the main controller of that Envoy process, or all the processes. It actually aggregates and distributes Envoy dynamic configuration to each instance. Citadel is the authorization piece, and Mixer is the telemetry collection piece, and it has the tie-in with policy, and it's all these, Pilot and Mixer especially are very pluggable. You can put adapters there. Pilot supports multiple environments like Eureka, Console, Cloud Foundry, in addition to the initial Kubernetes implementation. So the architecture continued in a different diagram. So we're going to use a reference application that is called Bookinfo, and it has several microservices. This is kind of like the view of how the communication paths are from the control plane point of view. You see that the dotted line there, I guess, each Envoy proxy is talking with Pilot to get its config, and the data path Mixer gets involved. So this is the more architecture of Bookinfo application. This is what we're going to use to show you guys the demo on having the mesh expansion. The gist of this is that there's a front-end service called product page. That's where the user interacts with, and that product page, to build its page, is going to talk to services called reviews and details, and reviews is going to talk to another service called ratings. And we're going to have multiple versions of the reviews service, and that's going to include different output of these stars. So when you see the product page, you'll see no stars for reviews v1, black stars for reviews v2, and red stars for reviews v3. We'll see all that we'll talk about that more when we go through that. So Kubernetes on Openstack. How do we integrate Istio with Openstack? It's built on Kubernetes. So how do we just to go over how do we support, how does Kubernetes work on Openstack? We have this idea of a Kubernetes admin. That admin creates clusters, and then there's a Kubernetes user that uses the Kubernetes cluster. The admin interacts with the OpenStack API, and the Kubernetes user just uses Kubernetes, doesn't use OpenStack APIs. How does that work? There's this OpenStack cloud provider. So Kubernetes services sometimes need stuff from the cloud, from the infrastructure. The main scenario for that with Istio is the Istio ingress, and that's implemented as a Kubernetes load balancer service type. So that means that there's a endpoint that's behind a virtual IP, and that needs to be exposed outside of the Kubernetes pod network. So that needs an IP on the regular network that your cloud is on. So OpenStack happens to have a load balancer service. So that's the OpenStack cloud provider interacts with the OpenStack load balancer as a service API to create that load balancer and plug those endpoints in. So this is a visual diagram of what I just told you. The Istio ingress is implemented as a load balancer service type, and the Openstack cloud provider runs in the Kubernetes cluster in the control plane for Kubernetes. It's configured by the cloud admin, the Kubernetes admin when they're making that cluster, and it has OpenStack credentials, and it talks to the OpenStack API. In this case, it's going to talk to the OpenStack Neutron load LBAS API to create a load balancer when that service is created in Kubernetes. This is a visual representation of the Neutron topology. When the topology view of after you've created two Kubernetes service types of load balancer, and the OpenStack cloud provider has used Octavia to create two Amphora VMs to implement those load balancers. So once we have Kubernetes deployed, you're going to need to be able to access. So to get the VM mesh expansion to work with Istio, that pod network needs to be reachable from the VM network. So how do we do that? The answer is routing. So the pod CIDR routes need to be propagated to the Neutron router on the tenant network where the OpenStack cluster, the Kubernetes cluster is being hosted. So this view on this slide is really showing kind of the same kind of thing is actually done in the CNI layer for Kubernetes. Each of those, if you envision those minion nodes for Kubernetes as they're each VMs with or baremetal with a namespace that's routing the pod traffic, that's the same idea that has to be happening at the Neutron router. So the OpenStack cloud provider can actually has a feature to propagate those pod CIDR routes to the Neutron router. So that's another integration point that's nice to have for this Istio scenario. So once that Neutron router has the pod CIDR routes, it can then directly access the pods from the tenant network. So now we're going to cut over to expanding the mesh across VMs.
Yeah, thanks, Tim. So one of the biggest use cases for this was what if you cannot move all your workloads to containers right away, or you have some sort of binding requirements to keep some of your workloads in VMs. So we came up with a list of reasons why would you want to expand the mesh instead of just moving your workloads to containers. Like a lot of enterprise workloads that still run in VMs. You might have some legacy applications which are not very container friendly. There are NFV workloads which require multiple interfaces which are not present in containers yet. As some examples, like you might have your applications running in containers, but your telemetry and logging outside, either on a bare metal machine or a VM. So you might not be able to containerize all your apps given like resource constraints like developer time and like just feasibility of an easy port to containerization. And some enterprise InfoSec teams are really concerned about security of containers since they have a shared kernel. So we've already seen this come up in many teams, like Kata containers and all might solve this issue up to some extent. But till then, we're still stuck with using VMs for some apps. You might already have a huge infrastructure invested in virtualization. Mostly like if you have a big OpenStack cluster already spun up, you don't want to tear all that down and just move to Kubernetes immediately. But you still want to reap all the benefits of deploying the apps on a service mesh, as in like Istio will allow you to do connection draining, rate limiting, canary deployments, easy upgrades, and like logging and telemetry. And the final use case, which I think would be the most common one, is you're simply just transitioning to a container-only infrastructure, but you just don't have the bandwidth to put all your apps at the same time. So you're going to do it piecemeal with some apps in containers. Some apps in VMs are slowly containerizing them one after the other. So just a quick demo on what, just a quick primer on what this demo does. It will spin up book info like Tim showed, all the components of book info on a Kubernetes cluster. Then we'll migrate the backend to a MySQL container on the Kubernetes cluster itself. Then we start an instance on Openstack, which is pre-provisioned with the MySQL requirements required to run the backend for book info. Then we provision the VM to join the Istio mesh, and basically we move the backend of book info from the containerized MySQL to a VM-based MySQL while using just Istio commands. So it's just a quick visual representation of what this demo is going to do. Is you create your basic book info pods. This is the product page, reviews, ratings, and you can see the Envoy sidecar comes up with all of them. Then you create a reviews v3 pod, and by default, Istio will round robin your queries across all instances of a service. I mean, all versions of a service. So if you have reviews v1, v2, v3, it's just going to split the traffic equally amongst all three. Here we have reviews and reviews v3. It's just going to split it 50-50. And you can actually create a new route rule. There's something like if you're doing like a canary deployment or a test from staging to production, you can deploy a new version, route like let's say 20% or 80% of your traffic, test if it works, and then simply just modify the same route rule to drain all the traffic, get rid of reviews, and move to the new version of your review service. So after that, we just deploy the ratings v2 pod. Ratings v1 has an intentional bug introduced in it to showcase some of Istio's capabilities, where ratings will not show you any ratings, and then v2 will actually show you ratings. And you apply the similar kind of route rules to drain all the traffic from ratings and migrate to a ratings v2. And all of this is done using very simple YAML. You don't have to write any code or anything. Each one of these route rules is like about 7 or 8 lines of YAML code. Then we deploy the ratings v2 MySQL pod, which is just the same as ratings v2, but it's actually backed by a MySQL container MySQL pod, and that kind of comes up along with the ratings v2 MySQL YAML. And you again apply the same route rules to drain traffic from reviews v3 to go to ratings v2 MySQL, backed by the MySQL in the container still. And then after that, we delete the MySQL service, backend service from the containers. And we delete it because we're going to replace it with an OpenStack MySQL VM. I know you're thinking you're actually deleting a service. We'll come back to that later. So when we spin up an OpenStack MySQL VM, so we actually came up with a script to run as a cloud init when you fire up the VM and you supply a little bit of metadata to the VM, and it is auto provisioned to join the Istio cluster. So we register it as it, and since we register it as a replacement service for MySQL DB, traffic just automatically starts flowing through here, and it starts using the VM as a MySQL backend. So just moving on to the actual live demo. Okay, now we need to see measure dash please.
So can folks read the screen there? Oh,
Sure.
We are SSH timed out, I think.
So we actually already spun up Istio 071, which is the latest stable release as of this demo. 08 is in the works.
I'm going to bump the font up a little.
Oh, some more. Okay, better. 08 is still in the works. It has got a huge amount of feature set, which actually addresses a lot of problems that we faced with when doing this demo. So we'll talk about that at the end of the demo. So you can see So you can see all the parts. We are actually not using MTLS in this one because we ran into some issues getting an MTLS connection going between the containers and the VM. But again, that is something that's promised fix in 0.8, so we will definitely try it with that. So you can see all the Istio ingress, mixer, and pilot, and the CA parts come up. This is before it migrated to the, we're not running the Citadel, it's still the old CA. So it also instantiates this Istio ingress service, which is the endpoint that we use to communicate or pull up book info in our browsers. And there's a mixer and pilot cluster IPs. They're just set up as cluster IPs with internal endpoints. And let's do. Okay, going into the demo. So you can see that Magnum has been set up. Like Tim showed, the cluster is ready. It's just a simple 2-node VM cluster. And we currently do not have any MySQL VMs. There's just a template VM that we use to create the MySQL template. Okay, that's the command to install. We already did that. So this is the first step to installing. You just apply the book info YAML. This is just going to bring up all the basic pods, your reviews V1, V2, V3, your ratings V1, and the product page. If we go to, I think we should see this time dot as well. Yeah, so I think my parts are still coming up. That's why it says no healthy upstream. Okay, there we go. So the reviews part hasn't come up yet, so that's why you see the reviews are currently unavailable. So this is just deploying the basic part, so you can see like to just do like a round robin across all. Some of the parts haven't come up yet, so like the reviews V2. So you will see alternating no stars, black stars, and then red stars. So it's just routing between the reviews V1, V2, V3 in the round robin fashion. We go ahead and apply. We give it the MySQL backend. So, yep, we move to the ratings V2. So this is the route rule that we're creating to tell Istio to bump all the traffic over to the route rules rating backed by the MySQL part. So if we go back, I think the MySQL part is still coming up. Yep, everything's up now. So we'll consistently see red stars 5 and 4 because it's being served consistently by ratings V2 backed by the MySQL part. Pump up the font. So you can see MySQL DB V1, and if you go to see, you don't get. So it has applied the 2 rules to consistently send the traffic over there. Now let's go ahead and boot up our Nova VM. So in this one, we actually created this template beforehand because it needs some DB root passwords and some of the table setup for book info. We put it on the same private IP as our Kubernetes minions, and we supply. So these are the files that we're sending it as a config drive, like the Kubernetes config, the certificates, cert key, and CA. We're giving it the test name to SSH, and then we're giving it a metadata. So pilot, let me talk about the script first. The -- user data, Openstack provision Istio. This is a script that we came up with to automatically provision this VM to join the Istio service mesh with all the parameters that we have specified in the command line. So what it's going to do is install Envoy on the VM, and I'm sorry, it installs the Istio proxy package on the VM, which automatically spins up Envoy. So what it does is it will capture a bunch of ports, like whatever ports you specify in this pilot ports, it will capture traffic going to all those ports on the VM and send the traffic over to Envoy, to the sidecar basically. So it's more like mocking the sidecar interaction with containers in the VM. Yeah, it takes a while. So it takes a little bit of time for the Nova VM to boot up. Shouldn't be long. And in the meantime, we go ahead and delete the MySQL DB service, and we register the VM that came up, the IP address of the VM that came up, and the port. So this registers a headless service in Kubernetes with pointing to an endpoint and port that you specify. So get endpoints, you see that MySQL DB has been registered as an endpoint, and so yeah, the MySQL DB service is acting as a cluster IP. If you go back to book info, so you should consistently, since we just modified the DB inside the VM from 5 and 4 stars to just 1 star, so you should consistently now see 1 red star because it's being served by the MySQL in the VM. So, yep, that was the whole demo. And going back to the slides. Yeah, so going forward, what all did we supply to the VM? What does the VM need? So we made a few assumptions here that the VM can talk to the Istio service, it can reach the pod endpoints, and for now it can be achieved using a net plugin like Calico or any kind of plugin that redistributes L3 routes or can somehow make the VM reach the pods and vice versa. That will work here. The VM needs the Kubernetes secrets. Of course, it does a few, at least the provisioning script actually uses a bunch of Kubernetes commands to grab all the pod IPs and everything and stick it in a host file on the VM itself. So we need the Kubernetes secrets in order for the VM to communicate to Kubernetes. And the last is the most important part, where the VM should be able to discover services on the Kubernetes cluster. So the way it resolves, Envoy resolves on the VM is it uses things like get me the endpoint for Istio pilot.istio system. So we need some sort of a DNS entry or some sort of a wave for the VM to be able to resolve all these endpoints into actual IPs and pods. So there's a few ways to do that. I mean, you can either do it with a DNS relay, a common DNS outside both systems. Right now, what the script does is it puts a bunch of entries in a DNS mask file, which is basically static entries pointing to the service IP of the Istio services on Kubernetes. I mean, using a DNS relay with a proper resolution would be the ideal scenario in this case. In case service IPs change or pod IPs change, you're actually covered in those cases. And it protects the containers just in case of restarts. Going forward, some of the future work that is needed in this area. is that we need like most of this was duct tape and glue and hacks around how we actually got it to work with OpenStack. So we need like a lot better integration, some sort of a native way for these VMs to join the Istio mesh. There are scripts which exist for GCE. We just wrote one for OpenStack, so we'll be pushing it soon to the Istio repository. There's not a native way. It's like there's no way for me to go ahead and define like a service mesh in OpenStack, like predefine a service mesh, pre-cache all the secrets and maybe the DNS information and the pod endpoint information, and just have like a single toggle when you're firing up a VM saying that this VM can join this mesh. So yeah, we have to resort to pretty hacky ways like bash scripts and everything to do this right now. And going back to the earlier point where I told you I deleted the MySQL endpoint, which is not a desirable thing to do in a service mesh ever. It kind of beats the whole point of a service mesh if you're deleting a service and replacing it with another one. What we would ideally like to do is register a VM as another endpoint to a service and use the same route rules to slowly drain and move all the traffic over to the VM and then delete your containerized services. This is fixed with the 0.8 release. I was talking to the developers of Istio. So there's a new concept called a virtual service and a service entry, which allows you to register arbitrary endpoints to any Kubernetes service. So I'll still have to test it out, so I'll update slides. So these are some of the references we followed. Just put it up on the screen. And that's about it. Any questions, comments?
Yeah.
No, I was just going to go back.
So the first two are just generic Istio docs that are up on the public doc rendering page. The second one is the procedure to integrate a VM, but Arvind, heavily implemented, customized that procedure for the OpenStack VM case, and that's what you saw on that Nova command line. That's the passing the parameters for that. And the third link is how we brought up Istio on Magnum specifically. I'm probably going to update that with a generic non-Magnum case as well, and describe the OpenStack cloud provider a lot more there. There's some good detail on the OpenStack cloud provider actually now in the Kubernetes document page. Using that with kubeadm is not really documented, so I have some details that I could add. So I'll probably add that to that GitHub page, my GitHub page with under that Istio link. But yeah, the main things there were just figuring out how to make the configuration automatic with kubeadm. Sorry, question?
Sure, Stu for Red Hat. As far as the virtual machine-based service you had there, was the Envoy deployed inside the virtual machine? And so would we actually need to use OpenStack for that, or could it be a bare metal-based virtual machine?
It could be anything. So Istio, it's just a package, a wrapper, Istio Proxy around Envoy, which is basically just configuring Envoy. So you could deploy that anywhere. There's no restrictions for OpenStack or anything like that.
Thank you.
Yeah, to restate that, the part that's just getting Envoy there and is one thing, and then setting up Envoy config to go and talk to the Istio control plane. That's what Arvind did in that script. Mm-hmm. So and then there had DNS resolution to be able to get to the
as long as it's an IP endpoint reachable by Kubernetes cluster, it can be deployed anywhere.
Yeah. So to follow up on that, I'm assuming that you knew a lot about that VM. It was a Linux VM, and you knew you had to put the right thing and all that. The kind of hack there. Does that mean that the real right place to point to put in a proxy layer, but basically what we're installing as a proxy here, would actually be within Neutron? That it shouldn't be within the VM itself, right? Because really what you're doing is you're affecting changes at the network layer.
Yeah. Mm-hmm.
So yeah, I want Istio to replace like Keystone middleware, right? I like the idea, but we need to work through the details here. And it seems like, did you consider that? Did you look into that? And what did you find looking into? That's really what I want. I want to know what your experiences were on the experiments that you tried that failed, not the hack that you showed on the screen. What does that look like at the Neutron layer?
So we did not actually spin up anything on the Neutron layer, but something we considered is we can instantiate one Envoy per network or per node and somehow route all the traffic to that, which is actually an experiment we can try, but we actually haven't done any, written any code towards it. Because this was a way which was already documented and working in the community, the way we did it with the bash script. So, and this is more vendor agnostic. We just showed it because it's more like an Openstack thing. People have Openstack clusters running and you want to bring in VMs to your mesh. So that's the reason we use the existing script to do that, but actually to your point, that's something worth trying out once.
Just the TLDR is kind of like we came at it a little bit more selfishly from the Istio side. Yeah, you're right. I mean, so we argued about exactly that point, right?
But you did think about it.
Yeah.
I understand trying to get something up here to show it. It's cool the way you show it.
Yeah, and we wanted to be able to share. It's kind of a
actually that's exactly the
community.
kind of input we need from the community
Yeah.
on how to make this a proper thing in the future.
Yeah, sorry.
One thing to be aware of, though, is that one of the concepts with the Istio Envoy is that it's part of a mesh of a specific service. And so having Envoy act as much like a load balancer as a service function means that now you have to deal with multi-tenancy in that Envoy instance. Just something to be aware of. I'm not saying you shouldn't do it, but you now have to manage that tenancy aspect as well.
It seems like it should be some property of the Neutron, where the VM is attached to the Neutron port. Do you say it's in there?
Yeah, that's
Sure, no multi-tenancy, but
I guess
the VM that's security that, then yes, you have that problem.
so like a per network or a per
we
per
were thinking of
subnet
it,
thing.
kind of analogous to the Octavia M4 VM or something, right? But or like an L3 router instance, almost at that architectural picture.
Within Neutron, when you create a network or a subnet, one of those abstractions there,
Yeah.
you can say, here's my envoy.
Yeah,
Maybe you say it is a VM here, so everything this is going to go and execute this code here.
right.
I think that's the right abstraction.
So
I have a couple of questions.
Yeah.
First one, these are VMs. If you containerized VMs, then that would be just a microservice, and then you can handle it directly, yeah?
You're talking about something like Kubernetes, where you bring up. Yeah, so that is basically the point of this is that you don't want to destroy your existing VM services.
Okay.
yeah,
That's the next one is Nginx, Envoy, is already can do this, yeah? Or no?
there's a lot of overlap with some of the features. I think so I'm not actually expert on Nginx, but my understanding is the power that Envoy gives you is there's this API discovery services that Envoy does. So it allows you to have like an external. That's what Pilot is an external server that on each Envoy instance will call an API for, and that will provide the response from that server will be the configuration that Envoy will use for until something changes.
Isn't that you already have the ingress gateway and egress gateway, so the external communication could be handled by.
Oh yeah. At the ingress, yeah. There are I think even folks using Istio with an Nginx gateway and ingress. Yeah, that's not unusual.
Can you do either synchronous or asynchronous communication? Like normal means, yeah.
Yeah.
By the way, the notion of IP in a service mesh is not really needed.
You're right.
Attacks,
So the thing that I was discussing with the IP, the routability. So if you think of service mesh as a distributed load balancer, that decision, the load balancing decision, is made at the sender, right? And so that sender needs to be able to reach every endpoint. So that if you're adding a VM into the service mesh, that VM needs to be able to reach every individual pod distinctly. So there's no, you're not going through another ingress to get into the Kubernetes cluster. You're going directly to the pods.
There is a basic philosophy when you define the service mesh. You want to think about smart endpoint and dumb pipes, yeah? Mm-hmm. In this example, you didn't go that far, no?
we set up the
It is a dump pipe.
infrastructure so that we could treat the pipes.
No, I mean,
It's two different things. I think you're mixing. So what we did, I described the integration of Kubernetes on Openstack, and that's where I kept it. That described how the IP was set, the routing was set up so that when we do run Istio on top, the service mesh works.
my last question. Okay, Istio is already incorporating two major features, the policy and the telemetry. Yeah? Is that in this experiment? Did you even consider that?
No,
We
did
didn't
not actually go
show any policy.
So we could have spun up Prometheus and Grafana. This was just more of a proof of concept to show that the mesh can be extended.
But in the demo, for sake of time, we
really did not go into the details of like what is your performance like when you extend your mesh.
Are you aware of the ONAP multi-cloud project?
Heard of it, but not
Yeah,
in detail.
Cloud, we are defining a mediation layer. So OpenStack is only one option.
Mm-hmm.
You can have any other commercial, like private cloud or even public cloud.
Yeah.
Then
Yeah, I mean,
create the namespace. You would basically define the cloud zone ID or cloud provider ID, and then you can plug in whatever the cloud you have.
Actually, we're sorry to interrupt. We're out of time.
Yeah. But yeah.
You can talk to us offline.
But
Thank
yeah,
you very much.
We can discuss multi-cloud with you. Thank you, everybody.